So today I will be going over the concepts of fractions and what a fraction really is. I'll talk about it in terms of just a numerator over denominator as being raised to the negative first power, and with a constant being multiplied to the numerator over denominator. So typically a fraction is in the standard form as a numerator over denominator, um, but that is its simplest form. There's also forms where there's a factor involved in between the numerator and the denominator, and that's when it's not in its simplest form. So the idea of simplification is to break it down to where the numerator and the denominator do not have any more factors that could be factored out of them and cancel. So you can see over here in terms of, if you like seeing it in terms of a formula, the factor over here for the numerator is c, which is also the factor for the denominator, d. And when they have the same factor, what happens is that the factor cancels and allows for the fraction to become simplified. So over here, I have an example of, let's just say, 10/20. As you can see, the factor of 10 has, or that 10 has a factor of 5, and it breaks up into 5 times 2. But you can also see that the factor of 20 also has a factor of 5 and becomes 5 times 4. And you can see later on that you can actually factor down even further, and you can turn 10 into 5 times 2 times 1, and turn 20 into 5 times 2 times 2. And what happens is that the 5s and the 2s are both factors of the 10 and the 20, and what you can do is actually cancel those values. And when you cancel those values, what you'll be left with is 1 over 2, or 1/2. And you can see that too, that if you multiply the numerator by 2, you would have a whole. That's really what a fraction is really saying. It's in terms of a ratio, it's saying that out of the whole, how many pieces do you have? If, let's say, we have a pie that's broken up into 20 pieces, of that whole pie that has 20 pieces, 10 of those pieces can be mine or yours or whoever you assign them to, or whatever we do with it. But that 10 is saying we're using 1 out of the, or that 10 is saying we're using 10 out of the 20. And when we simplify it, we're looking at that exact ratio and saying, okay, we're actually using 1 for every 2 slices that we have. And in this case, the 1/2. That is what a fraction is really saying. It's a factor. So what we want to do is also combine the terms in order to simplify. And I have highlighted right here that a term is basically just whatever is separated by a plus or a minus. So if you have, in this example, 5 plus 10, this numerator has 2 terms, 5 being one of them and the plus 10 being the other term. In the denominator, you have 1 term because there's no plus or no minus to separate it. But what you have right here in the numerator, you have a 15, but there's only 1 term because there's nothing separating those numbers. And then you have 10 plus 10 in the denominator, and it has 2 terms. Now, you can see through all 3 of these examples, they all are the same value, except they have different terms because they're broken up differently. And then in this last one, you can see that both the numerator and denominator have 2 terms. So that's just what I mean by the idea of terms. You also want to be able to make sure that you simplify all of the terms before you can simplify the whole fraction, because what would happen is that you would have a factor that goes into all of the terms, and you want to be able to compare a factor of all of the terms. So what you can see right here is we have that first example that we have, the 5 plus 10 over 20. We see that 5 and 10 both have a factor of 5, and 20, we'll get into that after this part right here. But you can see that 5 and 10 both have a factor of 5, and when you factor that 5 out of both of the numbers, 5 turns into 1, 10 turns into 2. And if you do use the idea of distribution, you can also double check yourself. But what you see here is that because both of those terms have a factor of 5, what we can try to do is see, okay, how else can we simplify this by looking at the denominator? And by looking at the denominator, we see that 20 has also a factor of 5 of 4. So we have 5 times 4, which gives you 20. So we see that 20 has a factor of 5. And now that we see that both the numerator and the denominator both have a factor of 5, what we can do is simplify it by canceling the 5's, allowing for the numerator to become 1 plus 2 and the denominator to become 4, which simplifies to 3/4. And what I will also get to talk about later on is that you want to make sure that the variables are equal. And what I mean by equal, you want to make sure that both of them are x, or both of them are x squared, things like that. Because when you simplify them, you want to make sure that you're simplifying them with the same sort of ratio. And I'll talk about that a little bit more later. So what about adding and subtracting fractions? Well, when you add and subtract a fraction, what you're really doing is you're talking about two separate ratios, and how those ratios going to be combined is determined by how can we first talk about them as one. And what I'm trying to say is, let's say you have 1/2 plus 1/2. Well, with 1/2, the ratio is saying that for every two parts of the pie, I get 1. And let's say we're trying to add that other half. Well, we're saying that same thing again. For every 2 parts of the pie, we're trying to add 1. Well, okay, so if they both have the same denominator, what they're both saying is out of the whole thing, there's 2 slices that can come together. And if you have one with one of the fractions and one with the other, you can add those numerators together, and that's saying that you're adding those 2 pieces together. And when you add those 2 pieces together, you can simplify the fraction, and you'll get 2/2, and 2/2 is saying out of the 2 whole pieces, you have 2, which simplifies to 1 whole. And in formula form, it would look something like this when you try to simplify. It's that a over b plus or minus c over b. So long as they have the same denominator, you can add the numerators together. But what you can see is that if the denominators are not equal, you cannot add them together and pick and choose the denominators. So what if we have two separate, and this is in terms of variables, so it looks a little bit more complicated, but what if we have two separate denominators and we want to be able to add these together? Well, there's ways that we can go about adding those together. So what we can do to be able to solve for this is that we can turn one of the denominators into the other. But in order to do that, we have to make sure that it's balanced. So one thing that we see right here is that we have one value of b, and over here we have 2 values of b. So what we can do is actually multiply this first fraction by 2/2. And what that would mean is that we're really multiplying by 1, because anything divided by itself is 1. But what that will allow for us to do is change the denominator so that the denominators will be equal to each other, and that we can do whatever we need to do with the numerator in the next step. So if we attach the 2/2 and multiply that to the a over b, what we will get is 2a over 2b plus or minus c over 2b. And now you would see that these two denominators are equal to each other, so that now we can combine the numerators. And because this is not just numbers, we have plus or minus whatever variables, we'll just keep the plus or minus, and that our answer will be 2a, or the first numerator, plus or minus the second numerator, which is c, divided by their common denominator, which is 2b. And in this case, this is its simplest form, because we cannot factor out a 2 from c, because c is the second term that does not have that missing factor. We can also use a method called cross-smile. If you've never heard of this method, basically what it is that what you would do is you would take the numerator of the first term and you would multiply it to the denominator of the second term. And then what you would do is whatever sign is in between, in this case we have a plus, you would take this plus sign and you would attach that afterwards, and then take the denominator of the first term, multiply that to the numerator of the second term, make that divided by everything, and then multiply the denominators of both the first and the second term. And what you see here is that in formula terms, a over b plus or minus c over d becomes the product of the numerator and of the first term and the denominator of the second term, keeping whatever sign in that order, and then the product of the denominator in the first term, numerator in the second term, and you'll divide that whole thing by the products of the denominators in both terms. If there was, let's say, 3 terms of fractions, what you would do is go in order in which you would do the first 2 fractions, simplify that into where you would have 1 fraction bar, and then constitute that first fraction bar that you came up with into the third term or the third fraction. That's when it gets a little bit more complicated in terms of conceptualizing how this formula would work. In this example, what we see is that 1/2 plus 3/4 is not saying the same thing. We have 1 out of 2 pies, and we're adding 3 out of 4 pies. Well, it's kind of difficult to visualize what it's saying if they're not talking about how many pies or how many slices of the pies you have in all. The ratio would be easier to understand, seeing that for every 1 we get 2, and for this one for every 3 we get 4. Well, if we take half of this 4, we know it's 2, but taking half of 3 does not give you an integer, and that would not really be equivalent to saying this sort of ratio, which have 2 integers in relation to each other. So that's where this cross mile method would come into play. So what you would do is you would take the 1 times the 4 plus the 2 times the 3 and divide that by 2 times 4, and you would just simplify. We have 4 plus 6 over 8, which becomes 10 over 8. With this first step that I showed you, we see that 10 and 8 both have a factor of 2, so you can turn 10 into 2 times 5 and 8 into 2 times 4, and those 2's would cancel and give you 5 over 4. But now let's throw in variables to make it just a little bit more complicated. Variables just adds one more piece to the puzzle that we have to look at. So let's look at, for example, 5x over 10y. We see that both 5 and 10 both share the factor of 5, and we can turn 5 into 5 times 1 and then multiply to x again, and we can turn 10 into 5 times 2 multiplied to y again. But what happens is that the 5's cancel and there are still variables remaining. The variables cannot factor out in such a way that they would be able to cancel because they're talking about different numbers. So what we're left with is some sort of, I quote, constant number, which is the dividing by 2, and then we have the ratio between x and y. In terms of simplifying, let's say, x over x, in order to simplify that, right here we have n raised to some sort of power and n raised to some other power. In order to simplify this from being a fraction into just a regular number, this would be taking the difference, whatever variable you have, as long as it's the same variable, you would take the difference in the exponents, so that you would take the exponent in the numerator and subtract the exponent in the denominator. So n raised to the a power divided by n raised to the b power becomes n raised to the a minus b power. And if you have a factor, it's literally the exact same formula, except c and d is their own fraction being multiplied to this relationship. So let's look at example 5 and see how we can simplify this. We see that they're both x, so we can try to simplify this in a certain way, looking at their exponents. We have x to the 5th power and x to the 3rd power. X to the 5th power divided by x to the 3rd power becomes just a single x, and then we take the difference of the exponents, which is 5 minus 3, and that becomes x squared. Now this only works for fractions with one term, because as you can see right here, once you add another term, you have to make sure that those different terms have the same factor that you can take out of it in order to cancel in a certain way. But because x and y are two different numbers that do not have any sort of a factor between them that are the same, x and y are two different numbers in their simplest terms, you cannot factor out a certain number which would allow for you to combine these in a certain way. There's no way to bring these two terms together. X and y are two different numbers, b and d are two different exponents. There's no way to bring them together. So what does an inverse look like? Well, when you get to higher level math, you'll start learning more about inverses. But what an inverse is really saying is that for every value that you have, it's a very, very small piece of that value. Or if you have a very small piece, it's a very, very large piece of that value. It's literally the exact opposite of what you're trying to say. If you have 2, the inverse of that is 1/2. If you have 10, the inverse of that is 1/10. Why is it like that? Well, it's because when you take a value and you raise it to the negative exponent of that value, what happens is you come out mathematically with 1 divided by that variable raised to the positive version of that exponent. So if you have n raised to the negative a power, it becomes 1 divided by n to the positive a value. So if you have n raised to the negative a power, that becomes 1 divided by n to the positive a power. And if you have a factor, that factor is the same thing as just multiplying to this fraction right here, which anything multiplied to 1 is itself. So c times 1 is c. So that's where you get c times n raised to the a power. C not being raised to any power because it's a constant. What you would have is just c divided by n to the a power. And you can see that an inverse can be represented as a fraction. The idea of an inverse is taking the idea of 1 for every x or y or n amount that you have of something. So right here we have 5 raised to the negative 2 power. Well, another way we can write that, the power is a negative 2. We can turn that negative 2 into a positive 2 by taking 1 over the base of 5 raised to the positive 2 power, and then 5 squared obviously is 25, so your answer would be 1 over 25. The reason why this formula works, though, is this concept right here. We know that from this equation that n raised to the negative a power is 1 over n to the a power, but why is that? Well, if you go back and understand, anything raised to a 0 power is basically saying that that number does not exist. So if you have 10 raised to the 0 power, it actually is 1, or n raised to the 0 power is actually 1, because the exponent is trying to say how many multiples of that number you have. And if you have no multiples of that number, well, you don't have that number at all. And the answer is not 0, because 0 is a value that can change the answer. So when you multiply by 1, multiplying by 1 does not change the answer. So that's the reason why that anything that does not exist when it's raised to the 0 power becomes 1. And we can see that applying in terms of working backwards to get to this formula. You can see that 1 over n to the a power, well, instead of saying 1, let's call that n to the 0 power. And we can see here that they both have the same variable and they both have exponents, and what we can do is take the difference in these exponents, and n raised to the 0 minus a power becomes n to the negative a power. That's what the negative a is basically saying. The positive 0 subtracting a. And when you subtract a to 0, it just becomes a negative a value. This can be b or c or whatever you want to say. It just becomes negative because 0 minus that number goes back in the number line that negative amount of times. So what about adding fractions with variables? Well, let's try it out. So we see here that 17 is a prime number in this example, so it's kind of difficult to manipulate this one like how we did in the second slide in order to combine the denominators and in this case subtract the numerators. So what we would have to do is use the idea of cross-cross-smile. So when we apply cross-cross-smile, the cross-cross-smile method in this case, you would take the 5x and multiply it to the 17x, or the 17y, sorry, and you would take the sign, which is the minus, and take 12y multiplied to 4x, and then take the product of the denominators, 12y times 17y, and when you simplify that, it becomes 85xy. The x and the y does not combine because these are two distinct different numbers in which we do not know what it is, so we can't say that it's a product in which is multiplied by twice itself or whatever. So that doesn't turn into x squared or y squared is what I'm trying to say. So you would keep that as 85xy minus 48xy divided by 204y squared. Now the y's are able to be squared because they're both the same variable, which is talking about we have two of these variables that are factors of each other, so that we're able to say that they are y squared. This is y to the first power, this is y to the first power. And what happens is that you would just add the exponents together, and 1 plus 1 is 2, which turns it into y squared. What we can also see here is that there's also a y in the numerator in both terms. This is where taking the two terms and having a factor in both of the terms to simplify it would work. So right here we see that y is a factor in both terms in the numerator. What we can do is take that y out and be left with 85x minus 48x, and we can also take that y factor out from y squared because this is saying that we have two y values being multiplied together. We can take one of those y values being multiplied and move it out front just to show how it would be able to simplify. Now we have two y's that can cancel, and when we cancel them, we get 85x minus 48x over 204y. And what we can do is, because they both involve x variable to the first power, we can take the difference in the numbers, which you can also do, if you can imagine this, is factoring out x and then just taking 85 minus 48 and redistributing that x to that value. What you would be left with is 37x divided by 204y. This is also, and I put as a note right here, this is also really just an xy ratio. It's mapping out for every whatever amount of y, you get this amount of x. And in this case, for every 204y, we get 37x. That's what that ratio is saying, where the 37 over 204 is just a constant multiple being applied to the number that is a factor of this whole thing. So what about complex fractions? How do we simplify these things? Well, this would make it a little bit more complicated, but what we can do is we can simplify it with certain rules that we have, and how we come up with those rules I can show you in a second. Typically, what you want to have a fraction in terms of is n over d. Right here we have a over b over c, a over c over d, or a over b over c over d. It looks extremely complicated in this form, but a fraction is mapping out one ratio, and that's mapping out the numerator to the denominator. So how do we get this in terms of just being a numerator, and this just being in terms of a denominator? Well, we would have to look at them individually, this as a numerator, this as a denominator, then this as a whole numerator, this as a numerator, this as a denominator, then this as a whole denominator. So how do we simplify that in a certain way? Well, there's one way that you can do this, and it's the idea of keep, change, flip, where what you would do is you would take the denominator and take the reciprocal of it. When you take the reciprocal of something, you're changing the numerator into the denominator and the denominator into the numerator. And then what would happen in the keep, change, flip format is that you would multiply that value to the numerator. So let me show you what I mean. In this sort of way, in terms of a formula format, a over b, and then that whole thing as a numerator, and then divided by c over d, and that whole thing as a denominator, you would take the c over d, which is the denominator, you would flip it and make it d over c, and multiply it to the numerator, which is a over b. When you simplify this, this becomes ad over cb. So what about in terms of numbers? How can we turn this in terms of numbers? Or to better understand this in terms of numbers? Well, let's simplify this one right here. Well, what we see here is 5 over 2 divided by 7. Well, 7 is the denominator, 5 over 2 is the numerator, but how can we switch the 7? How do we take the reciprocal of it? Well, the 7 is the same as saying 7 over 1. So what we can do is we can turn the 7 into a 7 over 1 and take the reciprocal of that value, which now we have in fraction form, and it becomes 1 over 7 multiplied to the numerator, which is 5 halves, and that becomes 5 over 14. So let's try another example, this time with a 7 on the top and 2/5 on the bottom. Well, what do we do with the 7 now? Well, this one you can also apply keep, change, flip, but it's just a little bit more simple. What we would do is you would take the denominator, the 2/5, take the reciprocal, turn it into 5 halves, and then multiply it to the numerator, and the numerator is just a whole number of 7. So it would become 7 times 5, which is 35, and divided by the 2. So it becomes 35 over 2. So now let's look at another example, but this time we'll have a fraction on the top and a fraction on the bottom, and we're going to include variables too. So right here we have 3x over y, and then that whole thing divided by 5x squared over 2. We can apply keep, change, flip and turn this denominator into 2 over 5x squared, multiply it to the numerator, which is 3x over y, and that would leave us with 6x divided by 5x squared over y. You can also see that they both involve an x, which you can factor out. And when you factor out that x from both of them, this x squared turns into just x, and you're left with 6 over 5xy. Now, as I was learning the keep, change, flip rule, I've started to recognize a pattern, and I'm not sure that this is a formula that's out or anything yet, but I decided to play around with it, and I saw that whenever there was a fraction on the top and a fraction on the bottom, they would always produce the same number or the same answer. And instead of simplifying the answer, I decided to keep them separated and just leave them as they're already factored out and see what kind of answers I get. And what I saw that A is always multiplied to D and B is always multiplied to C. And what I decided to do was call A and D the extremes and B and C the means. The reason why is because A and D are on the outmost side and B and C are on the innermost side. So I call this formula the product of the extremes divided by the product of the means. So let me show you how that would work and with that same example, but just using this in formula terms. So when I mean the product of the extremes divided by the product of the means, I'm referring to this formula right here, that A over B all divided by C over D is equal to A times D divided by B over C. So let's see if that works. So we have 3x over y all divided by 5x squared over 2. When we take the product of the extremes, I'm taking A, which is 3x, and D, which is 2. So 2 times 3x. Then I'm taking the means, the product of the means, which is y and 5x squared. So it becomes y times 5x squared. And what you're left with is 6x divided by 5x squared y. And when we factor that x out, we get the 6 over 5xy, which is the exact same answer that we got in the previous one. So that shows that this works. So what about more complicated fractions that we get? Such as if you're looking at a fraction that has a binomial in the numerator and then let's say a trinomial in the denominator and stuff like that. That's when it starts to get a little bit more complicated. And let's say that we want to be able to solve for a variable, let's say x, and we have an equation on either side. Well, when we have an equation on either side, we're saying that there's some sort of value for whatever variable we use. In this case, we use x. Most of the cases you use x. But there's a value for x in which it makes this equation true. Without x, this equation is not true. So there's some sort of value in x that makes this equation true. So in this example, we have 17x over 14 is equal to 12x squared over 7. What we can try to do is actually use two different methods for this. One way to solve for this is by multiplying by the denominator on both sides in order to get rid of the fractions. That's one way you can do it. There's another way in which if there's one term of a fraction on one side and another one term on the right side, you can use something called cross multiplication, where you would take the product of the numerator, or you would take the first term, or on the left side, the numerator, and multiply it to the first term in the right side, or the denominator. So in this case, you would take the 17x and multiply it to the 7, and then you would do the exact opposite, is you would then take the 14 and multiply it to the 12x squared. So let me show you in step-by-step process. So in multiplying by the denominator, by this first method, what you want to do is you want to be able to get rid of the denominator on both sides. And what you do to one side, you do to the other. So if we multiply both sides by 7, we're not changing the value at all. We're just changing the scale. And when we change the scale on the right side, what happens is it so happens to cancel with these 7s. And what happens is that there's a factor of 7 in the numerator and denominator that can cancel in a certain way too. So when we have 7 being multiplied to both sides, what we have is now 17x over 2 is equal to 12x squared, simplified it a little bit more. We also see that there's still another fraction, so what we can do is multiply again by the denominator, and that would allow for the denominators the denominator to cancel with that factor that we multiply on both sides, and it would just scale up the right side a little bit more. So what we would be left with is 2 times the 17x over 2. Those 2's will cancel, and it becomes equal to 2 times the 12x squared. Well, that then simplifies to 17x without the denominator equals 24x squared. Now we also see that there's an x in both sides, and what we can do is divide both sides by x, cancel them, and it becomes 17 is equal to 24x. When we solve for x, we would just divide both sides by 24 and we get 17 24ths. We should get the same answer if we use cross multiplication. This is just a different way of doing it. With cross multiplication, it might be a little bit more difficult. So sometimes you can use cross multiplication. Sometimes you can use multiplying both sides by the denominator. It just depends on the question. So if you use cross multiplication, what happens is you would take the 7, which is the denominator on one side, and you would multiply that to the 17x. Then you would take the 14, which is the denominator on the left side, multiply that to the 12x squared, and you would take the product of these two sides independently, and that becomes 119x equals 168x squared. You see obviously that you can factor out an x on both sides and divide both sides by x, and that will cancel one of them, and you would have 119 is equal to 168x. And what you can actually see, and it's a little bit difficult to see this, but the 119 and the 168 actually have a factor in common that you can simplify them. So when you solve for x, you would have 119 over 168, and then see what factors do they both share. And they both actually share a factor of 7. So when you factor out 7 of 119, you get 7 times 17, and you factor out the 7 from 168, you get 7 times 24. Those 7's will cancel, and you'll be left with the most simplified form, which is 17 over 24. So now let's do an example, putting everything that we learned together. So let's try to solve for x in this complicated equation that we have right here. What value of x would have to make this equation equal to each other? So in order to do this, you want to start small and work your way up. Let's start with the left side first. So on the left side, what we have is 5x over 2, all divided by 6x raised to the negative first power over 4, and then subtracting 4x squared over 6. Well, that's a lot to look at. Let's just look at one of the complicated fractions first. So what we can do is we can simplify the 5x over the 2 and divide that by 5x to the first power over 4. When we do that, we're going to do this in a couple of different steps. When we do this, we can apply the product of the extremes divided by the product of the means. That would make this turn into a simpler way because of the formula being simpler. It would just turn into 5x times 4 divided by 2 times 6x to the negative first power. That simplified becomes 20x divided by 12x to the first power. And 12x to the first power becomes, well, 12 turns into 4 times 3 because 4 is a multiple or a factor of 3, and it becomes 1 over x, or x to the negative first power becomes 1 over x, and that 1 over x is multiplied to the 4 times 3, so it becomes 4 times 3 divided by x. On the numerator, 20 has a factor of 4 also. It becomes 4 times 5 times x, and because we have this as another complicated fraction, what we can do is apply the keep change flip. And when we apply the keep change flip, we have the denominator 4 times 3 over x, and we can take the reciprocal of that. That becomes x over 4 times 3. Multiply that to the 4 times the 5x. And what you will see here is that the 4's will actually cancel. We have a 4 in the numerator right here being multiplied to it, and a 4 in the denominator. Those will cancel, and we will be left with x divided by 3, because the 4 is gone, multiplied to the 5x. You would also see that there's two values of x being multiplied together, so that can turn it into x squared with the 5 on the top as a factor of that in the numerator, so that becomes 5x squared over 3. That's the first part of the fraction. Now we can look at the second part, which is the minus 4x squared over 6. Well, simplifying that, what we have is a factor of 2 from the 4. We have 4 turning into 2 times 2. We also have a factor of 2 from the 6, which turns into 2 times 3. Well, those 2's will cancel, and what we're left with is the 2 and the 3. And that becomes, we just keep everything together, so that becomes minus 2x squared over 3. The second part wasn't so bad. And then what we would do to finish the left side is now put these two sub-answers together. Well, we have 5x squared over 3 minus 2x squared over 3. What we see here is that the fractions are both, or the denominators are both the same. So what we can do is actually just subtract both of the numerators. And that's just as simple as it could get for here. If they were different, then we would have to apply one of the other rules that we learned, where we would have to do cross smile, or we would have to manipulate it in a certain way. So when we combine these two fractions, we have the same denominator, and their denominator is 3. So then what we're looking at is that minus sign, and we have 5x squared minus the 2x squared. They both have x squared, So what we can do is we can factor that x squared out and take the difference in the numbers, which is the 5 minus 2, that becomes 3, and reattach that x squared. So we have 3x squared divided by 3. Both the numerator and denominator have they both have a constant number, which is 3, and those 3's will cancel, and that will give us x squared. So that whole thing on the left side just led us to see that it was equal to x squared. That's what simplification would do for you. So now let's look at just the right side. We see one thing that stands out already. We see 1 minus 2x on the top, but we also see 1 minus 2x on the bottom. Well, if we rearrange that in a certain way, let's say we put the 1 minus 2x in the denominator on the left side, we see that that whole thing in the parentheses is actually a factor of both the x cubed and the 4x squared. So what we can do is actually cancel the 1 minus 2x from both the numerator and the denominator. We would be left with x cubed divided by 4x squared. What you will also see is that we have some values of x with, it's the same variable x that we're solving for, but they have different exponents. So what we can do is actually change the 4 in a certain way. Because we're dividing it by 4, it's actually being multiplied by 1/4. That's the same way of dividing by 4 is the same as multiplying by 1/4. So in order to better see how we can combine the x cubed divided by x squared, that's the reason why I turned to the division by 4 into a multiplication of 1/4, just so we can see that it becomes x cubed divided by x squared. And what you would do is you would take the difference in the exponents, so it becomes x raised to the 3 minus 2, which just becomes x, and you would remultiply that x to 1 over 4, and x times 1 over 4 is just x over 4. This is the answer to the second part. So now what we have on the left side is x squared, and what we have on the right side is x over 4. In order to solve for this, we can apply one other way that we learned, which we can just multiply both sides by the 4. Because the left side is not a fraction, we don't have to do cross multiplication. We can just get rid of the 4 by multiplying both sides and scaling it up by 4. So what we would be left with is 4x squared on the left equals x on the right. And because there's an x in both the left and the right side, we can get rid of one of the x's by dividing both sides by x, which you do to one side, you do to the other. So then 4x squared becomes 4x, and x, well, anything divided by itself is 1, so x divided by x is 1. And then in order to solve for x, we just divide both sides by 4, and we would be left with x is equal to 1 over 4. So all in all, if you wanted to double check yourself, what you could do is then plug in 1 over 4 for every x that you see, and resolve and see if those two sides would be equal to each other. But now that we see, with everything that we learned, that even the most complicated fractions we would be able to solve for.